Okay, hello there my IM3 YouTube minions. We are on to 3-2 coordinate proofs. Very similar to 3-1, only we are using an XY coordinate system to do these proofs. Alright, there's a few basic rules here. You can maybe copy these down. When we play this game of proof, we are going to be representing any given figure on an XY axis. I'll show you an example in a minute. And we're allowed to take whatever figure we're doing a proof with and we're able to orient it in the most convenient way. Okay, so we can place it on that axis however we think best. We're going to use letters to represent the vertices or sides of things, and we can assign those variables to the givens and to represent the correct definition for the figure and occasionally properties, but we usually are focusing on just what the givens are in relation to the definitions. And then once we've got the figure placed on the XY axis, we'll use the distance formula, we'll use the midpoint formula, we'll use the fact that slopes for parallel lines are the same, or for perpendicular lines are negative reciprocals. That's the double flipperoo. And then of course we're going to use algebra to prove any desired properties. Alright, so on to the book, and let's just fade there, shall we? Okay, I want you to look on page 148 here in the textbook. I know reading a math textbook sometimes is a bit of a challenge, but these two examples are pretty good. They're just demonstrating how this whole coordinate proof thing works. They're saying show that the medians, that's the connection from a vertex to the midpoint of an opposite side of a triangle, that the medians drawn to the legs, and that's the legs are in an isosceles triangle, the two sides that are equal, that those medians are in and of themselves equal. Alright, so they start off doing pretty much what I said previously, that they're orienting this thing exactly how they want to. They've given it really simple coordinates. They're going out a distance and then going back that same exact distance, only negative. They've chosen 2a because it's convenience. They can choose any length that works, and 2a works the most easily. And then they're going up a distance of 2b, again because it's the most convenient. And then they just work out the math, and you can follow it. It's not rocket science. It just looks a little bit confusing at first. Continues on to the next page up here, and they're just using the distance formula, and they wind up with the distances being the same. And then they do the proof in the old school method that we did in 3-1, where they're doing it with just side angle side type steps and proving triangles are congruent, and then using CP/CTC. And they're asking you to provide the steps here in exercise 5, so you'll be looking at that in a little bit. Alright, okay, I've faded back in. Here I am doing an example similar to what you'll be asked to do in the book, and that is just prove that the mid-segment of a triangle is parallel to its base and half its length. Well, a mid-segment is a segment that goes from a midpoint of one side, so that's the midpoint we'll say, and is connected to the midpoint of another side, say that one. That is the mid-segment of a triangle, and we're going to say that we're going to try to prove that it's parallel to this base, and that this length here is half the length of that base. Okay, so as I said earlier, we are allowed to pick the orientation of this figure onto our axis however we think it's easiest, and I'm just going to start with the one point, the vertex on the origin, put another point out here and another point right there, and I'll connect these like this to make my triangle. Okay, and then I'm going to assign the coordinates to the vertices, so that's going to be 0, 0. That makes it easy. This, I can choose it to be anything, and I'm going to choose it to be 2a and then 0. I'm not going up and down anything because I'm on that axis. And it's going to be 2a because later when we're finding mid-segments, we'll be cutting things in half, and it's easier to cut 2a in half than just one of a. So then this point up here, can you guess what it's going to be? You guessed 2b. And then not 2b, that's 2c, and that's my bad Shakespearean joke. We've got our 3 coordinates for the triangle. Now we just find the midpoints based on our midpoint formula. Well, that is just that we add up the x's, 0 and 2b, add up 2b and 0, and you get 2b, cut it in half, you get b. add up 0 and 2c and cut it in half, and we get c. So the coordinates for that midpoint are simply b comma c. We do the same thing here with this midpoint. We add up 2a plus 2b, cut that in half, and we get a plus b for the x-coordinate. We don't know what these quantities are, but we know that whatever they are, it's going to be a plus b cut in half. And then we do the same thing with 2c plus 0, cut that in half, and we just get c. Okay? Well, to prove that this line here, this mid-segment, is parallel to the bottom, we just need to point out that the slope here, if we call this like k, l, and m, that the slope, m, for km is equal to 0, because my rise is 0 and then my run is 2a. Well, 0 over 2a gives me a slope of 0. If I do the same thing here, if I do my slope formula, you'll see my rise goes from c to c, and that's also 0, and then the run is this amount here, which we'll find in a second, but that's also 0. So I'm not even going to write out the algebra there, but you should in your homework. I don't want to clutter up the page, but if you put it into the slope formula, y1 minus y2 over x1 minus x2, you'll see the slopes then work out to be 0. I can give this letters k, l, m, and I'll call this o and p. So the slope OP also equals 0. That proves the first part, that it's parallel. These both are the same, therefore those segments are parallel. But then I want to show that this is half the length of this side. Well, this side km, the length of km is 2a. Well, the length of these two, I'm going to do that by just noting that because they're along the axis here, the distance is not going to change at all in the y dimension. It's only changing in the x dimension, and that's just going to be the difference of those two coordinates. So it's going to be the farther one, a plus b, then minus the first one, which is b, and that length equals a. So you could say then equals the length of OP. Okay? Whereas the length of km is equal to 2a, and that is indeed twice a. So there's a 2-to-1 ratio for the length, and there's parallel for the segments, and we've proven it. Okay? Thank you. Okay, just when you thought you were rid of me, I thought I would fade back in and show you that you really can put this into the distance formula and show that the distance between this point and this point is just, when you plug things in, you just get a squared plus 0 squared square rooted. And of course you do get a. So that's sort of the official mathematical way to prove what may seem pretty obvious. But there are times when you have to do that, so be aware. Thanks.